Hi guys, this is Conceptual Chemistry, Unit 16, and we're solving the exam review. This is for questions 8 through 13. Remember, during class we'll have all three formulas up on the board, so your task is to know when to use the formula and how to use it. So, for number 8, the question is saying calculate the hydrogen ion concentration of a solution if the hydroxide concentration was 4.5 times 10 to the negative 2 molar potassium hydroxide. Remember, if you have a hydroxide, an OH, in the formula of the substance, chances are it is probably a base, but in this case we know it is because we're saying that that OH is going to result in the hydroxide ion concentration. So, how do we know which formula to use for this problem? Well, our clue is that this problem gives us an H plus as well as an OH minus, so that means that we are going to want this guy over here. This is the only formula that gives us a hydrogen ion and a hydroxide ion concentration. So, to solve for this, what we're going to do is we are going to plug in the value they give us, and we're going to solve for the value they don't. So in this case, they do not give us the H plus concentration, but they do give us the OH minus, and the OH minus concentration is 4.5 times 10 to the negative 2. So we're going to do H plus times 4.5 times 10 to the negative 2 equals 1 times 10 to the negative 14. Okay, now to get H plus by itself, what we're going to need to do is we're going to need to divide. We're going to go on this side, we're going to divide by 4.5 times 10 to the negative 2, and then we're going to divide by the same amount on this side, 4.5 times 10 to the negative 2. They're going to cancel out on the left-hand side, but to get hydrogen ions by itself, right? And on the right-hand side, we're going to plug into our calculator 1 times 10 to the negative 14 divided by 4.5 times 10 to the negative 2. Make sure that you bring your own calculator tomorrow so that this doesn't mess you up. So when we solve this, it's going to give us an answer of 2.22 times 10 to the negative 13. So if that didn't work, if you put that in your calculator and you got a different answer, that means you need to go back and check your calculator, make sure that you know how to work your calculator to get the same answer that I do. Now for number 9, notice it says calculate the hydroxide ion if a solution has 0.0314 molar hydrochloric. Now there's nothing in here about H plus, right? Except that we're saying it's hydrochloric acid, which when we put it in water is going to split up, and it is going to make the H+. So here's the rule. If you see something talking about hydroxide ion concentrations, right, then chances are you're going to need, again, this formula that's on the left-hand side. Okay, hydroxide is your clue. Now when you get into higher level chemistry classes, you'll learn some exceptions to this rule, but for right now, this is how it works. If you get to a math problem that's asking about hydroxide, you need this formula. So to solve for this, we're going to go ahead and plug in what we know. So we know that the hydrogen ion concentration is 0.0314. Okay, and we know that if we multiply that times the concentration of hydroxide, that will always give us 1 times 10 to the negative 14. So then, to get hydroxide by itself, we simply divide again, just like we did in the previous problem. This case, it's going to be dividing by 0.0314 on both sides. Okay, they're going to cancel out on the left, and then on the right, we're going to get an answer of 3.18 times 10 to the negative 13. Again, double check that you get the same answer as I do. If not, then chances are you're having a problem with your calculator, and you need to spend some time making sure you can get the same answer. Okay, last problem. Calculate the pH of the following and describe if it's an acid or a base. So here is my clue in this question. They're asking about the pH. So I go up here to my formulas and notice this is the only problem with pH in it. So we're going to need to use that formula. Okay? So to solve for A, it's very easy. They gave us the hydrogen ion concentration, so I just need to plug it in. So I'm going to take the pH is equal to the negative log of the hydrogen ion concentration, which in this case is 1.7 times 10 to the negative 11. Now make sure that you're comfortable with how your calculator does this. For some of you, you're going to need to plug in the number, this guy, then you're going to need to take the log and then switch the sign. Other people have calculators where when you push the log button, it gives you the log and the parentheses, then you punch in the number and you can do it that way. The key is, remember, that you won't have any negative pH values. Okay? So when I plug this into my calculator, I'm going to get an answer of 10.76. You could round it off to 10.77, but we're in the same ballpark. Okay? Again, when I actually plug it in my calculator, because my calculator, I have to punch in the number, then hit the log button, I get negative 10.76, but then I just change it to a positive 10.76. Okay, now the last problem here, number 10. We need to, first of all, they're still asking for the pH, but we need to deal with this, okay? They give us hydroxide. Now, in order to solve for the pH, we need the hydrogen ion concentration. Notice up here that the formula always asks for the pH concentration. I mean, the hydrogen ion concentration, this guy, right? So we need to figure that out first. Okay, so what that means is because we have an OH minus, we actually need to start with the problem or the formula that is on the left so that we can get the hydrogen ion concentration and we can plug that into the pH formula. So this is like a two-step problem. So you're going to take the hydrogen ion concentration times the hydroxide, which is what they give us, 0.0000, let's see, there's 7 zeros there, 27, equals 1 times 10 to the negative 14. Right? But chances are you're not going to be able to punch that number into your calculator. So we're going to put this into scientific notation right now. So we zoom in here. 1, 2, 3, 4, 5, 6, 7, 8 spots to the right to put it in proper scientific notation. Remember, proper scientific notation means one non-zero in front of the decimal. So this is going to become 2.7 times 10, because this number was smaller than 1, remember that's your clue that it's a negative, and then the number of spots we move the decimal is 8, so it's going to be times 10 to the negative 8. Okay, so I'm going to erase this, and I'm going to replace it with, I'm going to replace it with 2.7 times 10 to the negative 8. Now I can punch this into my calculator, okay, which means to solve for protons, I'm going to need to divide by 2.7 times 10 to the negative 8 on the left, and I'm going to do the same thing on the right, 2.7 times 10 to the negative 8, okay, which means that my hydrogen ion concentration is going to equal 0.000000, so that's 6 zeros, 37. If you have your calculator in scientific mode, it's going to equal 3.7 times 10 to the negative 7. Okay? Now we can finally solve for the pH, because we needed this value. We needed the concentration of protons in order to solve for pH. So in order to solve for the pH is going to equal the negative log of 3.7 times 10 to the negative 7, and that is going to give us a value of 6.4, and that's your answer.